So let's draw resting membrane potential. This is going to be a picture of our cell at rest. What does it look like? What ions are high inside the cell? What's low?
So we're going to have a lot of potassium in the cell and a lot of sodium outside.
Okay? What else? We're going to have some voltage gates.
Yeah.
What two ions do we have gates for?
Sodium and potassium.
Yep. This is our sodium voltage gate. It looks like Nevada. And then we have our potassium. And we're going to draw 5 things at rest. We have 1, 2, with 3 more things we want to draw. We have negatively charged proteins. Their job is just to sit there being negative. You're going to make the cell negative 70 at rest. Okay, what else do we have? So what's our third one?
Would it just be like a different kind of gates? Like there's like the ligand.
So we're not going to draw any ligand ones at rest for this one, but we do have another type. It's the leak channel for potassium. So potassium leak. And our 5th one is going to be an ATP pump. You guys know what that one pumps? Or we could also call it a sodium potassium pump.
Is that the one that pumps them at the same time? They kind of just push past each other, or? Okay.
Basically, we're going to use ATP for energy to exchange 3 sodium ions for every 2 potassium ions.
Okay.
Why would we need energy for this process? Because we're going against the concentration gradient, right?
Yeah.
Naturally, this potassium is higher in here, so it's going to want to leave. Right? Go from high to a low. We have a little K out here. But we're making it keep getting bigger and bigger and bigger, so we'll need energy. Just kind of like a ball. If I put a ball on top of a slide, what does it naturally want to do? Yep, go high to a low. But if I'm going to be at the bottom and going to push that back up, I'm going to need to use energy, right? To go against the concentration gradient. It's unnatural movement. There's my 5th one. So there's my resting membrane potential, my cell at rest. I mean, negative 70. K is big inside, and then big outside. And then my 5 players. Okay? So let's draw an action potential curve. I'm at negative 70 at rest, right? There's me at rest. What happens in the cell to cause depolarization?
The sodium channels open.
Yep.
And they rush in, so then depolarization starts.
Yep. So sodium goes from a high concentration to a low, bringing with it its positive charge. So I start getting more positive inside the cell. What's this dotted line?
The threshold.
So I'm going to go up, depolarize, pass threshold, go to negative or to positive 20. I'm depolarizing. Polar opposites. They're no longer such drastic differences. We're going to come up. Is this my only gate that opens doing this? We have Na opens.
At the peak, the potassium opens, doesn't it? Is it the peak, or is it?
It's actually going to start to open doing depolarization.
Okay.
At the peak is when it's fully open.
Okay.
So that's key to know. Is that here it starts to open. And then right here, K is fully open. What else happens at the peak?
Sodium.
sodium's going to close. So if that's closed, I can't have any more positives coming in, right?
Yeah.
But if this one's now fully open, where's my K want to go? Inside or outside?
It's going to go out.
Oh, right. And why is that?
Because there's too much positive in there and it wants to like get out.
Mhm.
First negative.
The main reason is going to be we have a really high concentration of potassium. So we want to go from a high to a low. So it's going to be like, okay, let's go. Taking with it is positive charge. So if we start erasing these positives, what are we?
Negative.
We're just negative now. So that's why we start going down. That's called repolarization. Okay, at negative 70, we're back at rest, right? So this is going to be where the cell sends a signal to this K gate saying, all right, we're back at negative 70, you can go ahead and close now. But the gate's really slow to close, right? Just like it was slow to open.
Mm-hmm.
So while it's closing, I am still having positives leave, right?
Mm-hmm.
So if my positives are still leaving, I'm going to get even lower and lower, called hyperpolarization. Hyperpolarization. So maybe we're down to like maybe negative 90 now. At this point right here is going to be when my K closes.
So it doesn't close till cleared out by a couple of
Right here it's closing.
Okay.
At the very bottom of hyperpolarization, it's now closed. So here, both my gates are closed. And A as well. How do I get from this negative 90 back to negative 70? So let's draw what my gates look like. My gates right now are all closed, right?
So then the
It's
potassium.
negative, so it comes through the leak channel.
Yeah, so it comes with leak channels.
Well, my K is still going to be higher here.
Okay.
So this is always leaking out. It's always going from the high to a low. So my leak channel isn't going to be in charge of bringing it here. What is though? This guy. He's in charge of making this K even bigger and the Na even bigger outside. So it's going to build up our gradient difference even more so, which is going to bring us back to negative 70. Back to resting membrane potential. Do all those steps make sense?
Yeah.
Okay, because you'll want to know which gates are open at what point, what happens because of it, why does it happen, things like that. So if I were to put a bunch of points on this chart and ask you what's going on, what's happening here at point A?
The depolarization is happening because the sodium is opening, or they're opened,
Mm-hmm.
and the potassiums are slowly opening, so they're all leaving, so it's really negative.
Or it's leaving, so it's becoming more negative during point A?
Yeah, right? Or might you have that wrong?
Well, let's see. No, your gates are perfect. But what's happening? Is everything leaving or something's coming in?
Oh, they're coming in. So,
Right.
Okay.
This guy's coming in, so I'm actually getting more positive.
Okay.
I'm going up in numbers. It's right there. Yep, depolarizing. My Na gate's open, my K gate's opening. I'm becoming more positive because Na is coming inside the cell with its cation, a positive charge.
Okay.
Okay, what's happening right here at point B?
Not really anything yet. It's just kind of at the resting.
Mm-hmm. So what does my cell look like? What do my gates look like right there?
They're all closed.
Everything's closed. Okay, what's happening, or what is this? So this is an action potential. What's right here? This kind of area.
Like a sub-threshold or something like
This is
that?
a greater potential.
Okay.
Yep, so I'm below my threshold.
Okay.
So it's called a local or graded. potential.
So would it be the same on the other side?
Over here? No, because I've already passed threshold. Anything before threshold is going to be a local potential.
Okay.
So this is where our all or none principle comes into play. If I pass threshold, it's going to be all. If I'm anything below threshold, it's none. If I go above, I'm having an action potential. One action potential is going to conduct. If I'm anywhere below, no action potential. Okay? Does that make sense?
Yeah.
Do you want to go through it again, or do you feel confident in this?